Yes. So let's solve now few old gate questions. So first question goes like this: a periodic function f of t with period 2 pi can be represented as Fourier series representation given by this. So this is what? This is trigonometric Fourier series representation, and the function is given by f of t equal to a sin t from 0 to pi and 0 l. So question is we have to find out the coefficients a1 and b1. Okay. Yes. So let us try to plot the function. So the function looks like this. Okay, that function is what? A sin t. So it looks like this. So this is 0 to pi, and from pi to 2 pi it is 0, and again it is this is 2 pi. Okay, so then this is 3 pi, and then 4 pi you have, and the function goes on like this. Okay, right. And same is the case in negative time also. So this is a half wave rectified waveform for a sin t. Okay, so an equation of this curve is a sin t. Okay, so this information is given, and this they called it as f of t. Question is we have to find out a1 and b1. Okay, so what is ak we know, so that's why we write a1 to be equal to 2 by t integral 0 to t. I write general result. You should say x of t cos k omega, or not, yeah, k is 1, so I'll get cos omega naught t dt because k is 1. Okay, so this should be equal to what? So for the given function, period is given to be 2 pi. So you will get 2 by 2 pi, and because the function exists only from 0 to pi, it is the function has a non-zero value only from 0 to pi. So it is enough that we take from 0 to pi. X of t in this region, in this period, is 0 a sin t, and this fellow is multiplied with cos omega naught t. So capital T is 2 pi, omega naught t is 1, and hence you get cos t dt. Okay, so this 2 will get cancelled. So this would be equal to a by pi. So sin t cos t can be written as integral 0 to pi. Sin t cos t is how much here? You can write it as sin 2t divided by 2, and that 2 I'll keep it out, dt. Okay, so this should be equal to a by 2 pi. Integral of sin 2t is cos 2t, correct? So, or minus, integral of sin 2t is minus cos 2t, or yes, so integral of cos 2t is minus cos 2t. So divided by 2, and integral limits are from 0 to pi. Okay. Yes, so this should give you how much here? Minus a by 4 pi multiplied with cos 2 pi, correct? You replace t with pi, and 0 minus cos 0. So definitely this is equal to how much? 0. Why? Cos 2 pi is 1 and cos 0 is 1. So that is our a1. Okay, so we got a1 to be 0. Similarly, let us try to find out b1. b1 is again 2 by t. We will write generic result 0 to t x of t sine k is 1, so we'll get sine omega naught t dt. So this should be equal to, for the given problem, 2 by 2 pi integral 0 to pi, as usual. Why? The signal exists only from 0 to pi. X of t in this limit is a sine t multiplied with, again, omega naught is 1, you get sine t dt. Okay, right. So this should be equal to 2 will get cancelled out. You will get sine square t. Sine square t can be written as 1 minus cos 2t by 2. So we will write down that as a by 2 pi integral 0 to pi 1 minus cos 2t. Okay, you will get 1 minus cos 2t dt. So this should be equal to a by 2 pi. We'll split the integral 0 to pi 1 dt minus integral 0 to pi cos 2t dt. Okay, so this simplifies to, so this is a by 2 pi multiplied with this first fellow will be 5 pi, and minus this is sine integral of cos 2t is sine 2t by 2. Integral limits are 0 to pi. You can easily see that the second term is 0, so I am not writing that. So finally you get a by 2 pi multiplied with pi. So pi will get cancelled. Finally, you get the answer to be a by 2. So what is a1? A1 we got to be 0 and b1 is capital A by 2. So a1 is 0, b1 is a by 2. So which one is the answer? Choice D is the answer. Okay.